For this example, we're dealing with a revenue problem, which you should have seen before. The cost of a ticket to a hockey arena that seats 800 people is $3. At this price, every ticket is sold. The arena manager gets a bit greedy and considers increasing the ticket price. For every dollar increase, the attendance will fall by 100. Well, when we have this, we always know that the revenue is equal to the price per unit multiplied by the number of units sold. In this case, price per ticket multiplied by the number of tickets that we're actually selling. I can say that the revenue would equal, well, if I made no changes, it's going to be $3 multiplied by those 800 tickets I'm already selling. But in this case, if I do a $1 increase, so I do one change where X is going to represent the number of price increases, then I'm going to reduce the number of tickets sold by 100 times the number of price changes that occur. When I multiply this out and put it into general form, I'm going to state that R is equal to negative 100x squared plus 500x plus 2400. There's my general form when I multiply out that binomial. And that's also what I'm going to be graphing into my calculator. I'm going to graph y1 is equal to negative 100x squared plus 500x plus 2400. I'm going to change my window settings. I'm not going to be making too many changes, so I'm going to say that for the changes, or for my window settings, I'm going to go between -1, 10, and 1. For my y, because I know that if I didn't change anything, I'm already at 800 people, and if I have $3 times 800 people, I'm already starting at that 2400. I'm hoping to increase it from there. So I'm doing some pretty big numbers. I'm going to say -100, positive 4,000, and I'll make 500 the scale. And when I do that, I'm going to get something like this, where I'm going to graph it out. It's going to look something like this. I got my vertex, I got my y-intercept, I got my x-intercept. And my points are going to be at 0 and 2400, at 2.5 and 3025, and at 8 and 0. The x-intercept makes sense because if I go down by 100 people each time I do a price increase, I'm already only selling 800 tickets. Then after 8 times, I'm not selling any more tickets. If I'm determining the domain and the range for the situation, well, my domain is going to be represented by x, and I'm going to say that 0 is less than or equal to x, which is less than or equal to 8, where x, er. Why do I know that the lowest point is going to be 0? Because I'm already selling all 800 tickets. If I went -1 or reduced the cost down to $2, theoretically my sales would go up by 100 and go up to 900, but I'm already selling every ticket in this arena, so we know we can't sell more than 800, which means that I can't reduce X or do a price decrease in order to make that happen. My range, in this case, is my revenue, which we've already said is represented by R, where I can make $0 theoretically is less than or equal to R, which is less than or equal to the highest it hits, 3025, where R is an element of all real numbers. Determine the maximum revenue and the number of price increases to reach the maximum. That's just my vertex. Max revenue is the Y value, $3,025 after 2.5 price increases. Or my X value at the vertex. What's the new ticket price? Well, if I take a look right here, I said that it was price per unit multiplied by the number of units sold. My price per unit was 3 plus 1x. So if I'm determining the new ticket price, I have to say that my price is equal to 3 plus 1x, and we said at the max income, x was 2.5, so 3 plus 1 times 2.5, which is going to be 5.5, or $5.50 per ticket. If I'm determining new attendance, that was the other part. That was the number of units sold, 800 minus 100x. So what's the new attendance? It's going to be attendance is equal to 800 minus 100x, or 800 minus 100 times 2.5, which is going to give me 550. New attendance is 550 people. The last problem is going to be another area perimeter problem. In this case, we're going to do a slight variation, which is pretty common. A rectangle lot is bordered on one side by a river and on the other 3 sides by 600 meters of fencing. If I'm drawing a diagram labeling the width and the length, the first thing I'm going to do is I'm going to draw my river. I have 3 other sides, and I know that it's rectangular, and I'm going to say that this is my width, this is my width, and this is my length. I also know that 600 is equal to 2 widths plus a length, or the length is equal to 600 minus 2 widths. As I typically do, I'm going to replace my width with x. So I could say that the length is equal to 600 minus 2x. If the width is x, then write an expression for the area as a function of x. Well, area, once again, I'm going to say is y. So the area, y, is going to equal the width, which is x, multiplied by the length, which was 600 minus 2x. Or the area is equal to negative 2x squared plus 600x. that's what I'm going to be graphing. Negative 2x squared plus 600x. I'm going to change my window setting so I can fit this. And I can already see that I have 600 meters of fencing to prospectively use. So I'm going to say that I have negative 50, 500, and 50 are going to be my x values. Because, once again, it's an area one, if I said that all three sides were the same length and they were all 200, well, the length times the width would be 200 times 200. That's already 40,000. So I'm going to go with some pretty big numbers. Negative 5,000, positive 50,000, and then each one is going to be scaled at 5,000. I'm going to draw what this looks like on my calculator. And I get something that looks like this. My key points are at 0 and 0, at 300 and 0, and a vertex or a maximum point at 150 and 45,000. Determine the maximum area of the lot. Well, that's going to be my maximum point, 45,000 meters squared. What are the dimensions that produce this maximum area? Well, if x was my width, then my width at this point is equal to 150 meters. If my length was equal to 600 minus 2 widths, or 600 minus 2 times 150, my length was equal to 300 meters. So the dimensions are going to be 150 meters by 300 meters to make this happen.